right, class, this is Algebra 1, lesson 11.6, Pythagorean Theorem. All right, Pythagorean Theorem, and we'll do a few more things involved with aspects of the Pythagorean Theorem. All right, so 11.6 in your notes, please. All right, let me see if I can get that off. Okay, so we've got a right triangle there to the right. And so first off, let's make sure that we understand the parts of a right triangle. Parts of a right triangle. You can see here to the right, we've got a right triangle there for you. And we've got to make sure that we understand the parts of a right triangle. All right, right triangle has one right angle. One right angle. The Pythagorean theorem is for right triangles, and so it's important that we understand that we have a right triangle. All right, when you have the three sides, the longest side, you remember what it's called? You learned this in pre-algebra last year. The longest side is called the hypotenuse. Hypotenuse. Let me spell it again for you. Hypotenuse. It's the longest side. It's also across from the right angle and is always side C in the formula. So if you look at the triangle, here's the right angle, right? So what side is across from the right angle? You can see side C. And so this is our hypotenuse. Usually abbreviated HYP, right? Your hypotenuse right there across from the right angle. All right, the other two sides are called legs. So you have a hypotenuse and two legs. So side A is a leg, and side B is a leg. Two legs and a hypotenuse. Makes me think of two ducks and a big fat hen. All right, two legs and a hypotenuse. All right, before I get to the formula, let me show you a clip from The Wizard of Oz. So this is a clip from The Wizard of Oz, and this is when the Scarecrow gets his brain, and he's actually going to misquote. He is going to misquote the Pythagorean theorem. I mean, he's close, but he is misquoting it. All right, I hope you're going to be able to hear this. Oh, great. We got a commercial. Oh. All right, here it comes.
I hereby confer upon you the honorary degree of PhD. PhD? Doctor of Ecology. Sum the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side. Oh, George, I've got a brain. How can I?
All right, I hope all that worked. I know I had a little bit of technical difficulty there in the beginning, but you know, he says the sum of the squares of the sides of an isosceles triangle equals the square of the other side. Well, it was supposed to be not an isosceles triangle, but a right triangle. So our formula is a squared plus b squared. We are adding up or summing the square of the sides, and it's going to equal the square of the hypotenuse. So a squared plus b squared equals c squared, and that's the Pythagorean theorem. A squared plus b squared equals c squared. All right, so how do we use it? Well, there are three other forms if you want to solve for a side. And so really all you're doing is taking the Pythagorean theorem and solving it for either side A, side B, or side C. If you were solving for side A, you don't need to do this in your notes, but wouldn't you add a negative b squared to both sides? And then how do you get from a squared to a? Well, you should remember that we need to take the square root of both sides, right? So that's going to end up with then c squared minus b squared. I'm going to use my color here. So a is going to be the square root of c squared minus b squared. The second one is similar, and again, you don't have to memorize these if you know how to solve the equation for the given letter, and we should already be able to know how to do that. But again, if not, here's the simplified form. Oops, that needs to be a c. So if you're solving for side b, it is c squared minus a squared. And again, try and use my color here to make things similar. And then lastly, if you're solving for side c, you're already ready. If you look up at the original Pythagorean theorem, you're already ready to take the square root of both sides. It's just that the c is on the left and the a squared plus b squared is on the right. So what do you end up with? C equals the square root of a squared plus b squared. C equals the square root of a squared plus b squared. So again, you don't really need to learn each of these three if you know how to solve this. If you don't know how to solve the Pythagorean theorem, and again, we've already learned this, but in case you forget, then you're going to have to use each of these forms. This will allow you to find side A, this side B, and this side C. All right, make sure though you do know the Pythagorean theorem, the one that's boxed in, that you have got to know, you've got to know, you've got to know. Okay? All right, next thought here. The Pythagorean theorem can be used two ways. The Pythagorean theorem can be used two ways. The first way is to determine if a triangle is indeed a right triangle. Is a triangle a right triangle? There's no right angle symbol. Is a triangle a right triangle? Let me get rid of that shade so I can put this a little higher. All right, so don't worry about the second question. Let's take a look at the first. Here is our triangle. Remember, it is important that you always label the hypotenuse, or what we think is the hypotenuse. Now, how would you know whether it's the 9 or the 12 or the 15? You say, oh, the 15 because it's red. Well, if you get a problem, it's all going to be black and white. How would you know it was the 15? And you might say across from the right angle. Well, we don't know that that's a right angle. But remember, the hypotenuse is always the longest side. So we do know the C is the 15. All right, if you want, you make the 12 the A and the 9 the B. And look, it really doesn't matter if you flip them. It still will turn out correctly. All right, so now we're going to plug them into the formula. 12 squared plus 9 squared, and that better equal 15 squared. 12 squared plus 9 squared better equal 15 squared. So if you know the squares in your head, fine. If not, use your calculator. 12 squared is 144. 9 times 9 is 81. And 15 times 15, not everybody knows that one, is 225. Again, you can use your calculator for those numbers. Okay. Take your calculator if you need to, or do it in your head. What's 144 plus 81? Well, it is indeed 225. If this formula works, and it did, then yes, it is a right triangle, because the formula only works for right triangles. Yes, it is a right triangle. Okay, because the formula worked. Yes, it is a right triangle. All right, so then you also get problems like this where you don't have a picture. So notice our second example here, there's no picture. All right, what are we going to do with this? There is no picture. Okay, well, we have to determine which side is the hypotenuse. So if you had a 5, a 7, and a 23, which one would be the hypotenuse? All right, while you're thinking, I'm going to write the Pythagorean theorem. A squared plus b squared equals c squared. And you have to figure out which one is c. Well, you might say, oh, of course, the last one. First is a, the second is b, and the third is c. Well, is the last one the biggest number? What's the biggest number? Because that's going to be your hypotenuse. All right, obviously 7's bigger than 5, so 5's out. So it's either 7 or the square root of 23. Well, if you don't know how big the square root of 23 is, punch it into your calculator. But we know this, the square root of 25 is 5. So this number is less than 5. It's less than 5. So you know what? The hypotenuse has to be the 7. That's the hypotenuse, and that's what's got to go in the C. Okay, so let's go ahead and sub in our numbers. 5 squared plus square root of 23 squared should equal 7 squared. All right, 5 squared we know is 25. What about this one? Remember what I taught you about what do squares do to square roots? They undo them, right? And the answer is the radicand. So that's a 23. And we all know 7 squared is 49. So what's my left side? Oh, 48. You know what? This is really close. And you can have a square root and have it work. But I chose one that didn't, so this is a no, so it's not a right triangle, right? Because the Pythagorean theorem did not give us a left side that equals the right side. It always will. That's the way the formula is. If the formula works, it is a right triangle. If the formula does not work, it is not a right triangle. All right, what's the second way of using the Pythagorean theorem? To find the third side of a right triangle. All right, so you can use the formula to figure out if the triangle is a right triangle, but you can use it to find the third side, but only of a right triangle. Notice we have a right triangle. Good. Means we can use the Pythagorean theorem. All right, how do you solve for the hypotenuse? Again, if you don't remember the specific formula, go ahead and write the Pythagorean formula and go ahead and solve it for the variable you're looking for. All right? If not, you can use the formula I gave you. I'm going to show you both ways. All right? So here was the formula I gave you in the front. C equals the square root of a squared plus b squared. Okay? Don't neglect that square root symbol. Call one of the sides a and the other b. I'll call the 4a, and I'm going to call the 6b. All right? Again, it doesn't matter, although they are labeled a, b, and c. All right, so the a is 4, so this is going to be 4 squared, plus the b is 6, so this is going to be 6 squared. So c equals the square root of 16 plus 36, and c is the square root of 52. Now, you cannot simplify this. You cannot simplify this until you add them up. Don't get mixed up between simplifying when things are being multiplied and simplifying when they're being added. The other thing I see students do all the time is forget the square root symbol. Don't forget that square root symbol. See how my work is orderly? All right, the last thing I got to do here is I've got to simplify, if I can. A 52 is a 2 times 26, and a 26 is 2 times 13. Notice I can take the square root of the 2 times 2, and my final answer, c equals 2 times the square root of 3. All right, that's doing it if you remember the solved formula for the hypotenuse. Let's say you didn't. So you can either put this in your notes or not, but here's how you do it. A squared plus b squared equals c squared. Put in the value for a, put in the value for b, equals c squared, and then, of course, take the square root of both sides. All right? Now, at this point, you're fine. You could have added them first and then took the square root of both sides, or done it now. Remember, we don't do plus or minus because we're dealing with a distance. Triangles don't have negative sides. And if you'll notice, I'm not going to finish it off, but we're right back at the same point, right? You end up with the square root of 52, and then you got to simplify, and you end up in the same place. All right, so if you can't remember the specific formula for the side, then you better just use the Pythagorean theorem and solve it. All right, it's probably the better way to go anyhow, because most people can remember the Pythagorean theorem. Let's do a second example. You're going to find the leg. It could be A or B. It could be X or Y or Z. It doesn't really matter. Just understand the proper formula. And again, if you don't know, just use the Pythagorean theorem. Okay? I'm going to use the Pythagorean theorem. A squared plus B squared equals C squared. Okay, we're solving for A, right? C is always the hypotenuse. The other leg is B. All right, piece of cake. So what do I have? A squared plus, what is my B? A 6. 6 squared equals, what is my C? A 10. 10 squared. At this point, you can actually simplify this. Simplify that, right? A squared equals 36 plus 100. Let's move our 36 to the other side by adding its opposite to both sides. I end up with A squared equals 64. Let's take the square root of both sides. square root of the left, square root of the right. Again, I do not use the plus minus because distance is only positive. So A equals 8. And there is my triangle. By the way, this was a form of a 3, 4, 5 triangle. It's a similar triangle to a 3, 4, 5. It's a double of it, an enlargement. So instead of 3, 4, 5, we have 6, 8, 10. All right, and so the value of A is 8. Okay, that's how you're going to find the hypotenuse. That's how you're going to find the side. What's next? What's next? Go ahead and move this up. What's next is when we are going to seek to figure out the distance between 2 points. Let me erase that, give myself a little bit more room. All right, so to find the distance, and that's what goes in the blank, to find the distance between 2 points, use the distance formula, which is a form of the Pythagorean theorem. It's a form of the Pythagorean theorem. And this formula is going to allow us to figure out the distance between 2 points without having to draw it. Now I've got an illustration here to help us understand it. All right, so right here I've got a picture. And we've got 2 points, and I've got the point -2, 1, which is that point right there, and then I got the point 3, 4, which is that point right there. Now, if I had a picture, I could easily solve this by simply making a right triangle out of this. Notice, keep getting my wrong pen, sorry about that. Notice how this forms a right triangle. And if I needed to know the distance of the bottom, I could count the squares, right? 1, 2, 3, 4, 5, right? It is 5, so write 1, 2, 3, 4, 5. So from the one point horizontally to the other is a 5. And I can do that vertically, right? There's 1, 2, 3, right? And so that side is 3. And if I wanted to, I could use the Pythagorean theorem. Now remember, that's the hypotenuse. So c squared equals a squared plus b squared, right? So if I take the square root of both sides, that was sloppy. If I take the square root of both sides, then c is going to equal the square root of a squared plus b squared. Okay, let's sub in our values. Oh, we are so sloppy today. All right, so c equals the square root. Call one of them a, call the other one b. I'll use the 5 as the a, and I'll use the 3 as the b. So c is going to be the square root of 25 plus 9, and c is the square root of 34. And what is c? The distance between the 2 points, square root of 34. Well, we have a formula that will allow us to figure out the 5 and the 3. If you remember way back for the slope formula, figuring out the slope of 2 points, we labeled our points. We're going to do that again. This is the x of point 1. This is the x of point 2. This is the y of point 1, and this is the y of point 2, right? So again, you have the x and y coordinates of point 1, the x and y coordinates of point 2, right? X and y coordinates of point 1, x and y coordinates of point 2. So, how could you get this 5? Well, watch. If I did 3 minus a minus 2, doesn't that equal 5? It does. And this is where the formula comes from. And how do I get to 3? If I do 4 minus 1, don't I get 3? I do. And that's the way the formula works. So watch. Need a parentheses. X of 2, the coordinate of point 2. Take my red minus, back to my blue, x of point 1, quantity squared, I'm going to do that in red, and then plus, because I'm finding the hypotenuse, and now I'm going to do the y of point 2, use my red, minus, back to blue, the y of point 1, quantity squared. All right, so let me give you a second to write that. x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. Hey, this is just a form of the Pythagorean theorem. So if I now use the values they gave us, let's go ahead and solve this. All right, what was x sub 2? 3. Use my red again, minus. What is x sub 1? Negative 2 quantity squared, right? So we have 3 minus a minus 2 quantity squared plus, I'm following the formula, right? Parentheses, what's y sub 2? And hopefully you say 4. What does the formula say? Minus, what's y sub 1? 1. And what does the formula say? Quantity squared. All right, we got to do what's in the parentheses first. 3 minus a minus 2 is a 5 squared, plus 4 minus a 1 is a 3 squared. Do you notice at this point how we are just like here? Only we have a d instead of a c, the distance instead of the hypotenuse. It's exactly the same. We would finish it the same. You get this d equals the square root of 25 plus 9. And finally, d equals the square root of 34. And by the way, you cannot simplify the square root of 34. All right, what I want you to do is I want you to try this second one on your own. Let me just remind you again, it's wise to mark your points x sub 1, y of 1, x sub 2, y sub 2. And you know me, I want you to write the formula because you got to start learning it and remembering it. So go ahead and pause the video, and it's my advice that you try to do this problem on your own with the video paused and then unpause it. All right, so hopefully you did the problem. So you wrote your formula. It just takes a second. Every time you write it, it helps you to remember it, right? Every time you write it, it helps you to remember it. Got everything labeled. Okay, x sub 2 is negative 7. Minus from the formula, x sub 1 is a 3, quantity squared. Plus sign. Y sub 2, 0. Careful now, minus from the formula and a negative 2 coordinate. And so where do we end up with? D equals a negative 10 squared, which by the way, if you made that positive 10, it wouldn't matter. Because negative 10 times negative 10 is 100, and 10 times 10 is 100. Plus, that's a positive 2 quantity squared. Again, it would not even matter in this situation. All right, so let's see where we end up. D equals the square root of 100, right? Negative 10 times negative 10 is 100, plus 4. So D is the square root of 104. And now, remember, look to simplify. Hey, does this thing simplify? You always got to look to simplify. How about a 2, and a 52? Okay, yeah, I see already. I got another 2 right here. 2 and a 26. But you know what? A 26 is a 2 and a 13. So that's going to be it. But I can take the square root of a 2 times 2. And I end up with 2 times the square root of 26. And that is the distance. All right, so look. This prevented us from having to draw a picture to make a Cartesian plane, to make a grid and count the sides of the triangle. The formula figures out the sides of the triangle by using the coordinates. The formula figures out the sides of the right triangle, the two legs, by using the coordinates of the points. So all you're really doing is solving for the hypotenuse of the Pythagorean theorem, and that's the distance. All right, last thing, midpoint. This is an easy formula. You want to know the midpoint. So if you look to the right here at the illustration, I want to know what point is halfway between those 2 points. All right? Half the distance. Again, there's the whole distance, right? I want to know what are the coordinates of the halfway point. Okay, that's what we're after. And it's a simple formula. Again, you want to label your points x1, y1, right? The x coordinate 0.1, y coordinate 0.1, x sub 2, y sub 2, y coordinate, x coordinate 0.2, y coordinate 0.2. Okay. All right, here's the formula. It's pretty simplistic. X of 1 plus x sub 2. This time you're adding. Take your blue and divide whatever you get by 2. How do you get your y coordinate? y sub 1 plus y sub 2 divided by 2. In the midpoint formula, you add them, and you go 1 plus 2. In the distance formula, be careful now, you go final minus initial, and you subtract it. Don't get the 2 mixed up. But that's it. That's a pretty simplistic formula. See if it works. All right, so our midpoint is going to be, should have a parentheses there, actually. Put those in, please. All right, and so I'm going to do my x-coordinate. What is the x-coordinate? X sub 1 is a negative 2. What is x sub 2? It's an ugly x sub 2, but it's a 3. And I got to divide that by 2. And to get my y-coordinate, I got to do y sub 1, which is a 1, plus y sub 2, which is a 4. And again, I got to divide by 2. So what are the coordinates of my midpoint? Negative 2 plus 3 is a 1, so I get 1 half. 4 and 1 is a 5, so I get 5 halves. The midpoint should be the point with coordinates 1 half, 5 halves. Let's look at the graph. Here's a half on the x, and here's 5 and a half, or 2 and a half, I'm sorry, 5 halves, right? Is 2 and a half on the y. So the midpoint should be right about there. Doesn't that look like the midpoint? It sure looks like the midpoint to me, and it is. All right, the formula will get it exactly right every single time. Every single time. All right, so one last problem. Why don't you try this one again, pause the video, and go ahead and see if you can find the coordinates of the midpoint. Go ahead and pause the video. I'm going to give the answer right now, so you want to pause it so you can practice. All right, so again, always start with the formula because you got to get used to it. Add the x-coordinates, divide by 2. Add the y-coordinates, divide by 2. Just takes a second to write it. I'm going to be smart and label so I don't mix anything up. Excuse me. All right, x of 1 is 3 plus x of 2 and negative 7 over 2. Y of 1 is a negative 2 plus y of 2 is a 0 over 2. All right, be careful. This is a negative 4. All right. Positive 3 and negative 7 is negative 4, so we end up with a negative 2 for the x-coordinate. And the y-coordinate ends up being negative 2 divided by 2, and that's a negative 1, and you should have gotten the coordinates negative 2, negative 1. Hey, that's the way it's done. That's the way it's done. So how do we start everything off? And that is with the Pythagorean theorem. Remember, it is very important that you understand that a squared plus b squared equals c squared. And remember, the hypotenuse, the longest side, the side opposite the right angle, is the hypotenuse. What two ways can we use the Pythagorean theorem? We can use it to figure out if a triangle is indeed a right triangle. The Pythagorean theorem would be true if that's the case when you sub in the values. How else can you use the Pythagorean theorem? To find either the hypotenuse or the leg, right? You can use it to find, and that's a common use, to find either the value of the hypotenuse or the value of a leg. We then had a distance formula. Remember, what is it? A form of the Pythagorean theorem. What does it do? It allows us to figure out the sides of the right triangle without using the coordinates. What else do we have? We have a midpoint formula, which allows us to figure out the coordinates of the midpoint of a line segment. All right, that's the lesson. Your homework is at the bottom of your page there. And so we'll work on that in class tomorrow. No homework tonight. Just watch the video. Hopefully you've got complete notes, and we'll work on the homework in class tomorrow.